So without further ado, I'd like to introduce Heath Hockenberry. Heath is a National Weather Service employee, and he is based out of Boise, Idaho, and he's really focusing on supplying impact-based decision support services to those decision makers that are fighting wildfires. And you don't really have to be watching television every day to know how bad the wildfire season has been in 2017. That threat continues into 2018. And we'll discuss perhaps reasons why that is after Heath's talk. But let me show you a story that was produced by the Weather Channel. It's about a minute, 30 seconds on one of the fires that occurred this year. Let's take a look at that, and then we'll start with Heath's presentation.
Okay, we're on the Thomas Fire in Ventura County, just off the 101, and this, just in the past couple minutes, has popped up with the winds as the offshore flow comes in and starts whipping these flames around. This hillside, as you can see on both sides, is basically a moonscape, but this one has a lot of dry chaparral to burn. You can hear it crackling here. This is part of 65,000 acres that have already burned at this point, 12,000 structures that are threatened, and 150 that have been destroyed. But no loss of life at this point because they were able to get the word out in Ventura County for this fire and tell everybody to leave because it was very dangerous. I'm going to walk away from here because this fire is coming up the ridge here and coming towards the 101. And even though I'm wearing fire retardant clothing, I don't want to be standing anywhere near the fire that is coming up the hill because as those flames lick up the side of this ridge, it's going to get very close to us in any moment. So that is the very latest as the ash kind of gets in my eyes here in Ventura County, California on the Thomas Fire. I'm Dave Malkoff, the Weather Channel.
And you're back.
Hey, good morning, and thanks for having me. Yeah, that's an interesting picture there. And yeah, I'll get right to it. I'm Heath Hockenberry. I'm working out of Boise, Idaho. Why Boise? Because Central Idaho is the fire capital of the United States, actually. You'd think of Southern California. There's a little bit more urban interface there, obviously, than what Boise has, but we do have, by volume, a lot of fire in western Montana and Central Idaho. So, speaking of the last video clip, I'm not sure if you can read that or see it. As a reporter saying it's unbelievably hot here, the smoke is making it hard to breathe. Back to you in New York. If TV reporters covered forest fires like they do other storms. So that's the problem that we have, and it's kind of funny, but it does show you the distance we have to keep from these things. So you don't really get that up close and personal feel of a fire unless you're standing there right next to that radiant heat. So I do respect the reporters that can get that close. What kind of partners do we have for this? They extend the whole way from local fire departments, the whole way through the regional level system. That center graphic with all the nice colors there are the Geographic Area Coordination Centers. Those GACs, as we call them, move all the resources around to fight fires. We're talking about the large aircraft that you see dropping retardant, the single-seat, single-engine aircraft, and the hotshot crews and the main resources are all distributed by those regional geographic area centers to fight fire. And then at the national level, where I am at the National Interagency Fire Center, we're able to call in international resources. The big 747 air tanker drops that you see in Southern California, that is controlled and distributed and prioritized. I would say prioritization is the #1 function at the National Interagency Fire Center. And we do have partners, and our agreement is through the federal system, but the states are so involved that we have to have partnerships as well at that level. And I'm going to dive right into the types of forecast services that are provided, first off, at the weather forecast offices scattered across the United States. We have spot forecasts. Spot forecasts are extremely critical. What a local emergency manager can do, or a local fire official, is to directly request a forecast for a specific point on the ground. I'm not sure, by show of hands, how many people know about these spot forecasts or have ever seen one. Yeah. So those come in, they come in pre-populated and prescripted through our AWIP system, If a local, somebody out of Des Moines, Iowa wants a spot forecast, there are certain elements that they typically request. Those are already automatically in there, and they can add other elements if something else is in need. So we have 5 portals to go through where an emergency manager can request a spot. It can either be for a wildfire, prescribed, marine incident, hazardous materials, search and rescue. And our average over the last 5 or 6 years, 20,000. We do 20,000 across the United States. We set a record in 2017, 25,870. The #1 office that gets these requests is Medford, Oregon. And we also have a lot of requests from Missoula and Pendleton, Oregon as well. You might be surprised in the east. Anybody want to take a guess at our 1 or 2 of our top offices from South Carolina to Maine?
Chattanooga.
Sorry?
Chattanooga.
Chattanooga, you're close. It's actually South Carolina. We have Greer, Columbia, and State College, Pennsylvania. State College requested over 300 spot requests this year. A lot of them for a hazardous material event, over 118. So this is a train crash. Yeah, so, but I look back through 2014, and those 3 offices in the east are #1. And in the central United States, it's Grand Junction, Colorado. Red flag warnings. This is a subject, red flag developed in California. It developed where people would literally pull red flags up a flagpole when events would occur so that everybody could look going down the road that it was a critical day. It developed into the name of our core warning product. We issue over 8,000 of these per year. There's reasons for that, and they appear in our fire weather planning forecast. So, verification of red flag warnings. What actually makes a red flag and makes it real? Is it a fire on the ground? Is it the criteria that are met? And it's the latter. And those criteria are just a set of what's typically 4 or 3 factors. Wind, humidity, instability is another one, and fuels. That's the real variable at the tail end, fuels. If the fuels are not ready to burn and you have all those weather criteria in place, there's no warning. So we actually have cases where the weather doesn't quite meet the criteria, but the land agencies request that we actually put these things out. So there are various ways of verifying how these things are working out. And given that we put the power of defining this criteria at the local level, it creates dozens of red flag criteria. We don't have, dime size, nickel size hail and one-stop shopping here. We have to have local fuels driving this and local criteria. So we literally have dozens of criteria, but we are seeking ways to streamline that from the 10,000-foot level. Other items that we do, we offer, I heard at lunch a few people talking about consistent messaging. And so this is one of the key underlying factors of how effective our services are. Communicating an accurate and consistent message. So all the forecast offices that have a fire desk usually provide a briefing, either accompanied by a series of graphics on a briefing page, or they just keep these pages updated with the latest information. So briefings via web, via GoToMeeting are very critical in this day and age. We also have the capability of using our grids, or a National Weather Service set of forecasts, and we can actually define local areas and restrict the topography. This is a website that you can visit. It's the Userdefined area forecast, and I use this a lot when I go out to fires. I can restrict it to just say I want a weather forecast for an area in topography between 2,000 and 8,000 feet. I can use our grids to generate that. I just click through, define an area, and then, sorry it's so small, but I'll make it bigger next time. But it basically gives us a min and max forecast for the next 5 forecast periods over that area. The Storm Prediction Center, very much like they put out outlined areas of severe weather, they do the same thing for fire. On day 1, day 2, day 3 to 8, And the Storm Prediction Center also runs our SREF guidance. It's very hard to see, but along the right side, there's a fire tab. And those criteria that we talk about, the mixture of low humidity, high winds, instability, those options are already on the right side. So it actually takes our NAM forecast, and we're able to go through. This example is all areas that are below 20% relative humidity from a couple of days ago. So we can actually use those guidance products from SPC. NCEP, we heard Dr. LaPenta talking about NCEP support. They run a 1.5 kilometer nested grid that we can move around the country over areas of interest. You can see very small patch postage stamp over Southern California right there. That's where the grid is currently located. And this is very valuable for IMET services and also smoke. We definitely include our smoke air resource advisors and smoke regulators in the states. They love this product. They absolutely adore how they can just centralize a 1.5 kilometer grid forecast over a particular spot, and it runs out 36 hours. So that is how NCEP supports us. NESDIS has fire and smoke products, and we heard that great presentation on Monday on the support that satellites are providing. So you can go to the NESDIS site and find fire and aerosols and concentrations of PM 2.5 as derived from the satellites. They have a fire and smoke initiative to make sure that their products are moving from research to operations as well. You can see the graphics here. That is the Detweiler fire and another one in central Idaho. You can see the vertically integrated smoke forecast that results from the fire and smoke initiative from NCEP. Or not NCEP, but NESDIS, sorry. Now, a little bit of behind the curtain insight here. Maybe, hopefully you'll learn something new today. This is the National Fire Danger Rating System forecast that we provide. I'm wondering if anybody's ever ventured out to the product suite and seen this.
I do it every day.
You do it every day? Excellent. So this is the way, I think it was BASF. We don't make a lot of the products you buy. We make a lot of the products you buy better. So this is one of those behind the Wizard of Oz curtain products that we do. We have a forecast for a particular spot on the map associated with what's called a RAWS station, a remote automated weather station. These stations are owned and operated by the land agencies in the boonies, in the middle of nowhere, but they're sited for worst case conditions in fire-prone areas. So we issue a forecast for the next day at 1 p.m. for that particular spot in space. That is used to crunch numbers through a system called WIMS, and out pops fire danger. And what do all these numbers feed into? That beast. I'm going to spend about 10 minutes explaining this. Just kidding. Blue up the top, inputs. That's where we come in. We provide the weather input. Things are calculated through WIMS. Output, those 4 things on the bottom are key elements. Ignition component. How efficient will lightning start fires? Spread component. How will fire spread? Burning index, very influenced by the wind. How fast is it going to spread? And then energy release component. That is an index that determines long-term fire danger. Not fire behavior, but fire danger. All right, so all that boiled down into what does it mean? What do those numbers do? On the left, you see what's called a pocket card. An 18-year-old firefighter gets these in critical areas where they're out of their local area, they are responding to a fire into topography and in a location that they're not used to fighting fire. So we provide them typical fire indices. How is it measured against normals for this time of year? What years, in case they fought fire before, you might be able to see 2000 and 1995 years to remember. They give them similar years to remember how did the fire behave then. So our numbers feed into these pocket cards, and also, most visibly, the National Fire Danger Rating System helps set public land use. So in this case, Smokey Bear's Arm. So what you saw back here eventually becomes this. And that's just the tip of the iceberg of what happens. Okay, now I'm going to go into incident meteorology. I'm one. That's me, kind of right there. So yeah, you can tell from the back there. Yeah. I got the substandard backpack there, but yeah, we're all wearing Nomex. It's required PPE, personal protective equipment, hard hats, and you might be able to see some air operations there. I was getting wet. They were spraying some water, and that's the Okefenokee Swamp in 2012. So yes, swamps do burn. What do IMETs do? We go out. We get out of the office, and we are embedded with the incident command team. And we have 250 plus extra hours of training. And what we do is we apply conceptual models to the forecast environment. What do we use? We got our kestrels. We got our hotspot phones. That's me again putting up a weather balloon. We can actually take mobile soundings using either a GRA or Intermet system. Intermet is based in Michigan, and GRA is a German product. So I'm sure there's going to be others popping up here and there. But we can actually track in real time vertical distribution of temperature and get typical soundings right from the incident. And in the bottom right-hand corner, you can see a station. We actually set up mobile observation stations. Those are absolutely critical. So what do we do when we're out there? Aside from briefing on various levels in the morning and the afternoon, talking to plans, talking to tactics, going to public service meetings and public town halls as well in the middle of the fire, this is a product that has been really valuable for us. We actually have, we're talking about impact catalogs. Along the bottom, you'll see burning conditions that are helped set up by our fire behavior analysts and those people familiar with the local area on critical thresholds. And they're color-coded, green, yellow, red. Very simple. And we're able to put in what they want, and it turns colors by day. You know, will a combination of factors change the fire conditions on a particular day? And what factor is driving it? Is it precipitation chance? Is it ridgetop winds? Could it be a maximum temperature? I mean, that's really critical. And I know in Virginia, one of their red flag criteria is they can't issue one east of the Blue Ridge if the temperature is lower than 75. So depending on where you go, people feel that there are different criteria that drive the fire. So this is a very successful product that we were able to brief very quickly on so people get a snapshot. Where do IMETs go the most? This is kind of a squished map here, but you can see where the focal point of IMET distribution is and where the incident command teams go. They go to the Pacific Northwest, and there are areas in Georgia and South Carolina and northern Florida as well in the east, and then the southwest area in the springtime, anytime from March through July until their monsoons kick in, and then Alaska as well. We've had a few to Hawaii, too, for volcano fires. So this year, compared to, let me take some time, we have an average line there. You can kind of see the very bottom line as it appears in the green. We have an average of from 1987 to the last year. We have the current year in a dark black, thicker line, and the maximum all time. And that green envelope is one standard deviation away. So this year, I'm sure you can kind of follow it. As we crossed around July 4th, we crossed the average line and never went back. It was an exceptionally busy year for us, and we ended up with 200 dispatches, which is not the all-time record. We're still below 2006's and the year 2000. Those were banner years for us as well. So this year came in third place as far as the number of times we were requested to go. But the number of hours that we were out far exceeded anything we had done before. Like 30,000 extra hours. We were out there longer, we were out there later. So this gives you a kind of a depiction of how many of us were out at one time. I'll draw your attention to the peak of the red line. Our record is 44 of us from the forecast offices positioned with incident command teams all at once. There are only a set number of incident command teams, so that there were even more fires out there. That's about the max we could possibly do anyway, because there'll be no one around to request us. Everyone is out. But you can see the black is shifted to the right, so we were out later in California this year. So some basic IMET statistics. We have 76 of us across the country. 65 out of the 76 went out on fires this year, an average of 3 times, 11 days. When we get the request to when we're in camp, the average time of response is about 15 hours. Our bags are packed and we're ready to go. Yes.
Joe Murgo from WTAJ in Pennsylvania.
We're engaging the mic.
Go ahead.
Joe Murgo from WTAJ in Altoona State College. And with these stats and everything like that, and the National Weather Service in State College, I actually was tweeting out about this, and they say hi. But they want to know, is there a place that we can go online and see the spot requests and a map where the spot requests were actually, you know, do you have a map of that on your website?
Yes, we have a spot monitor page, and I can get that distributed somehow to the group here. It's kind of for the forecaster benefit to make sure that they're following up, and they have to manually close out things just to make sure that incident is closed down, but I think it's publicly available.
Okay, I'll give you my card and I'll pass it to them. Thanks.
Okay. Yeah, our spots that we issue are able to be read as well. So the average distance where we go, 702 miles. We do take eastern IMETs from Burlington, Vermont, and Gray, Maine, and send them to the Pacific Northwest. And that's why we train like we do. We train for a standard set of skills, 250 hours to make sure we know exactly what we're doing. And the number one thing is communication, briefing skills. Because you're talking to, sorry?
Not safety?
Briefing for safety. Yes. That's the number one thing, is to make sure that we get the 18-year-old kids that are out there covered, as well as the incident command overhead team and the incident commander as well. 9.8 million acres. NOAA, according to internal reports, 18 billion. I'm sure you could find different numbers even higher than that. But it was the deadliest season since the 1930s. Who or what starts fires? That's sometimes a question. This is a study from 1986 to 1996, especially over the west, lightning. As you move towards the east, it's more human-caused, and you can take a guess at what that spike is. July 4th. It's the firework effect, so that's what creates that artificial bump in the system. But when you're looking at absolute numbers, lightning edges out humans for starting a fire. So the famous fire triangle, who's heard of this before? It's how we operate. Weather, fuels, topography. It's ingrained in every firefighter. Everybody that is out there dressed in nomex has been trained in this. And the most highly variable part of the triangle, of course, is weather. So what do we train firefighters to look out for, and what do we brief on? Inversions. It's a huge fire concern. It affects aircraft operations. It affects search and rescue when necessary, and evacuations. It also affects the fire behavior. When these things bust, when the inversion, when the cap's eroded, boom, within 15 minutes your fire can explode. So we try to time these things, and that's why we put up the weather balloons, and that's why we're there following the weather day after day, to make sure that we can get a good sense of the timing on these things. Low intensity fires, the environment controls the fire. It's kind of a nice burn. These are exact ideal conditions when the Forest Service lights fires on purpose for fuel reduction and safety and getting the bad fuels out of the way. This is exactly what they're going for. They're going for a low to moderate intensity fire that doesn't get out of control. Now, high intensity fires, instability, heat, fire controls the environment. How so? We have a vertical dimension of fire. We've got dust devils and fire whirls. Those things are pretty impressive when you have a tornado of fire moving across your fire line. Many videos, you can Google it. There's tons of examples of fire whirls. Gusty surface winds, convection columns, big mushroom clouds, and firebrands that cause fires and spotting elsewhere. The type of winds that we have to be very specific of what wind we're briefing on. Is it the general scale? Is it local scale winds? Is it the 20-foot wind? And again, the 20-foot is associated with those raw stations. Those raw stations typically have mass where things are being measured 20 feet above the ground. And then there's mid-flame wind speed, and I'll get into that in a little bit. So how do we adjust winds on fire when the forecast models aren't quite there with that coupled fire atmosphere dynamic yet? We use conceptual models. We consult Dr. David Whiteman's book on mountain meteorology. If you have that in your library, it's a great way to get in tune with what these conceptual models are all about. So basically, on a clear, hot day in the west, we look at our topo maps. We go out and hike the fire and get a sense of how the land is laid out. And we apply these conceptual models. And we actually don't go with the general forecast. We forecast upslope, up valley, down slope. So this gives you a picture on the eastern slopes. That's where the sun hits first. You're going to get upslope flow, and then it kind of hits the southern slopes as the sun gets higher in the sky. We're going to get some upslope speeds as well. And then by the time the afternoon rolls around and the maximum heating, the western-facing slopes will get that upslope convective type of flow. So you can see the graph, the way the winds vary. So putting all this into words in a written forecast is very, very hard to do. So that's the art in our business. And that kind of gives you an idea, again, of what our slope and valley wind systems are that we forecast for. So mid-flame wind, that bottom wind, the one that is the firefighters actually standing in, we have to make sure that we pay attention to sheltering, position on the slope. So you can see how the wind through unsheltered fuels will be greater than somebody standing under that fully sheltered canopy. And whether you're standing at the valley versus fighting fire in the mid-slope as well. You're going to get more direct impingement of the wind when you're standing mid-slope. So we actually have adjustment tables that are done. We take our 20-foot wind speed that is forecast, and then if we're forecasting for a particular operation, how the fire is going to behave, we do reduce significantly those wind speed forecasts for mid-flame wind speed. Unsheltered, partially sheltered, fully sheltered. You can see by the time you get into dense stands, we are taking 90% off the wind, because that's what's experienced. Unless you're getting a gust flow from a thunderstorm, this is the free air winds that you're going to be experiencing when you're standing out in canopy. Sea breeze patterns, those are huge in Florida and Georgia, and obviously onshore offslope makes all the difference in Southern California. So those patterns are being monitored as well. And this is the scariest one. Other than big pyrocumulus, is the outflow. It's what happened at Yarnell when the hotshot crew got trapped. A gust front went through, microburst, and these things just spread out across everywhere. And the tricky part is there's sometimes precursor shifts as well, where a crew will experience a slight wind shift. It'll move back, and they think that was the wind shift, and then the real one comes through. So the atmosphere, it gets really, really tricky out there. So this is something we pay attention to in our spot forecasts. This is a criteria for updating them. And it's also the most important thing that we're doing out on the fire on convective days, making sure that these fronts are detected and reported over the radio. And we walk around with radios. If we see something, we can go on air right away. Santa Ana winds. I forget who it was. It might have been David Whiteman that said that you pronounce phone like Inspector Clouseau says phone, a phone, like phone winds. But I was actually on HBO last night, the Steve Martin version. Yeah, but phone winds, the Santa Anas. Not to make light of it, but this, these Santa Anas, I get questions all the time when these things happen in November and December. Is this rare? Is this? It's really not. The Santa Ana season runs the whole way from October 1 to Christmas, typically, any time during those, because you get these huge cold systems diving across the Great Basin, and there you go. You're off to the races. You get those compression winds.
Just something related to climate change on this that we've noticed over the years is that there is no longer really a Santa Ana season. I mean, with all the high amplitude of the jet stream patterns, it seems like at least once a month someone's writing a forecast discussion saying, oh yeah, and I increased the winds for the Santa Anas in Southern California. So it's really not, and same thing with the fire season. It's kind of like with this high amplitude, you can get these ridges, it gets dry, and times when it normally doesn't. So it's kind of, I'm sure your season has been expanded.
Yeah, kind of to give you a perspective on that, in 2000, when I first got into the program, we had 34 IMETs, and they were adequate to respond to the needs that are out there. Now we have, what I have up there, 78, 76, 78, and we're getting maxed out. So it's getting longer, it's getting difficult, and we're out there a lot longer. And again, some of that is a function of the value that we demonstrate out there. They want to hold on to. I was out on a fire this year where my end forecast needs were, when's it going to snow? When's the snow going to come in? So I was forecasting snow. I was doing more of winter weather than I was fire weather, but they wouldn't release me because they had equipment out there. They had values at risk and people. So we're being held on to a lot longer than we used to. Fire whirls, those are huge problems. You get extreme lower level instability, and then you can introduce that into your briefing. Plume-dominated fires. We got some really exciting research coming up through San Jose State University. They're actually going to take a mobile Doppler and those weather balloon soundings, and a small team is going to be positioned, excuse me, in Boise, Idaho, next fire season, not this upcoming, but next, to actually go out and directly measure the atmosphere in these plume-dominated situations. So we're going to be able to understand them a lot better in the next few years. Fuels. Interesting things are happening on the fire agency side. Take a stab at, prior to 2016, how many different fuel types were classified in the federal land management system? 100. 100 is a little too much, but
68.
40, actually 40. And do we have a question before I move on?
Question. There's something like that.
Thanks, Jennifer. Matt Safino, KGW, Portland, Oregon. When San Jose State does the mobile Doppler next season, is that going to be like an incident response, or they send it when requested to a specific fire? And how long will it take them to get a Doppler? Let's say I have to go from Boise to Southern Oregon. How long will that take?
Yeah, since they're pre-positioned along with the incident command teams, I mean, they're going to have the latest information of what has just happened or where the fires are being reported. We have 2 IMETs plus 2 of us in Boise, so there's 4 IMETs around too. So they'll be able to get there in less than 12 hours. It's car loaded or trailer loaded and ready to go. I don't know exactly what it's going to look like, but that's the goal. So hopefully, it's through the National Science Center, and I shouldn't say that they're promised this. I think they're requesting funding as well. So I'm really hopeful that the funding comes through for them to operate in that way. So we have those partnerships.
So you talk about Jennifer Gavina from Paducah. Do you do any long-term incident planning, like after the significant drought in California? Do you guys put a plan together into how to respond to large-scale incidents following that?
Do you mean the after effects of fire, or?
No, after a long period of drought in an area that would be high risk then for a major event.
Yeah.
Do you plan ahead for?
Yeah, there are long-term assessments done. In the mid-range scale, there's the FS Pro system that projects out 2 weeks. And then the longer range, we follow up with products from CPC and the Boulder folks that do the climate prediction. And now that we have the climate forecast system, we've got 30 days of data. So what we do is we partner with predictive services. They're fire agency meteorologists. They're in those GACs that I showed you in the first colorful image from. There's Central Colorado has one, and Paducah, your servicing area would be Atlanta. I think. So they continually to produce forecast products on a geographic scale out for the season. And it's fire potential, and it's related to the likelihood that outside area resources are going to be needed. It's less of a weather forecast and more of, are we going to need to request an equipment? So it becomes less of that weather event and more of a, can we fight the fire that we're expecting with what we have? And so, yeah, we are working with CPC to get more mid-range fire weather products out, but seasonal specific fire weather forecasting, it's more translated and morphed into a resource issue. Does that answer your question?
Yeah, I just wondered about how far out, sorry. Yes, you answered the question. I was just,
Okay.
I was just interested in how far out the planning goes, you know, long term, especially after years of severe drought in California. You know what I mean? Like,
Yeah.
you look ahead and you're like, man, you know, this next season, when things start to change a little bit, or the risk goes up even further, then is there planning involved? Basically?
Yeah, it extends into burned area recovery as well. There's teams called BEAR teams, burned area emergency response to flooding and hydro concerns when the soil turns hydrophobic. And so we have that long-term strategy. So we actually have hydrologists on the Forest Service side and the Weather Service side that respond after the effects as well, too. So.
Okay. Well, now you piqued my interest in the Gatlinburg case.
Yeah.
I don't know if you were involved with that or know much about it, but I guess the response was, so it was unexpected how quickly it would travel.
Yeah.
And so, do you know what the challenges were with that, or how the response?
I think my recollection is a nighttime event, and a lot of the people affected were, you know, I'm just don't know exactly, tourists.
There's a lot of tourists.
Out of area people.
Right.
So what we have is a social science effort going on right now. The study's due out in March of this year. So we're trying to better capture
From
those.
that fire? That particular fire, or just
No,
in general?
in general.
Okay.
We had that emotion right at the tail end of the Gatlinburg experience, so we want to put out better calls to action and message better and make sure that we capture the people that are out of area. And that happens in the West all the time. You get tourists out there that are just visiting, and you know, they might get caught out as well. So we're trying to message better for the public, because historically our mission has been internal. Red flag warnings are designed for fire management. They're not designed for the public. And we're trying to do that, a better job of messaging for that. So, okay. How am I doing on time? Good. Fuel, so that 40 fuel models in 2016 has been reduced back to, I believe, 4. In 2016, changes were made in the fire danger system to only allow for the following fuel types. I don't have a picture of slash. Slash is when things are cut down and you get a whole bunch of junk across the ground from cut down or blow down. So that's one model, but this is your typical timber fuel stand. Here we are in the southeast, palmetto, gallberry plants. These plants have oils that are extremely combustible when they don't get rain every 7 days. Brush, chaparral, items that you see across the desert Southwest and Southern California, also available to burn. And there's more grass. Tons of things out there, different types to burn. Thank you. Where'd I put this? I'll go over here. Did I see another question or not? Okay. Flame length. This is where it really gets into what we consider impact-based forecasting. Flame length directly determines the tactics and the pieces of equipment that you use to fight the fire. So flame length and a flaming zone in this particular example means when a flame, you saw that reporter at the beginning of the presentation, he could only stand so close. And that fire, I would estimate, maybe 12 feet tall, something like that. So a crew has a certain capacity to fight that fire depending on directly on the flame length. So here we are, these fancy nomograms that were developed back in the 60s and 70s. When you have a rate of spread on the left-hand column combined with the heat, the radiant heat of the fire, as you move up to the northeast on this graph, you can only fight fire in that small zone by hand, where the radiant heat and rate of spread are relatively low. As you move up in radiant heat or rate of spread, you have to call in bigger equipment. And then you go to aircraft. And finally, by the time that you see things go pyro-Q, you basically got to get out of the way and take pictures. It becomes really nasty. There are things that you can do during the big flare-ups to protect particular communities. That's why you see these firefighters getting so close in the urban interface. And they're out there doing what they can by indirect means. So, again, back to the great preview question. Informing the public. Do you think that the Weather Service is kind of like NASA, monitoring every single fire that's out there and having this control? So actually, the Fire Center in Boise is configured like this. It very much is like this. But it's not like this in the Weather Service, I would say, yet. Because this is the scale of the problem. I think this is a fire outbreak in Siberia. You can see all these different hot spots. Things are burning, and it does look like that in the United States now and then, but this was the most dramatic example I could find, is that monitoring thousands of fires a day is extremely difficult. It has been extremely difficult, but with GOES, things are changing. So what we have in place right now to inform the public are the system that's based on fire danger. We've got the Smoky Bear system. We have Ready, Set, Go programs through the fire agencies. We have fire-adapted communities as well. And the Ready, Set, Go initiative right there is probably the key item where citizens can pre-prepare for events. What communication is going to be made when fires happen, et cetera. But if you want a snapshot of what we can do right now to prepare communities and people, Ready, Set, Go is a place to visit, as well as monitoring the fire danger as well. Now, future warning and detection capabilities. Where we'd like to take the program in the future is not just having a red flag warning system that's not really what you would think of as a warning. It's more of a glorified watch. Well, all these conditions line up in the Swiss cheese. If the criteria is met, we pull the trigger. What we'd like to do is to take advantage of the detection capabilities and the spread capabilities and the algorithms that you can find on GOES to actually warn for fire that is actually occurring and to monitor its behavior. It's something that we've never been to remotely sense before in real time. We're going to be able to do this. So, GOES 16, fire detection algorithms, lightning detection. It potentially has the chance or the basis to improve lead time and be integrated into our red flag warning program. Here's a picture of the lightning detection capabilities. So an example from February this past year, we were able to work with the Texas A&M Forest Service and emergency managers in Oklahoma to actually get word out 4 days in advance. And to actually use GOES to detect where the fires were going to occur. And that picture on the right side are the outlined probabilities that were generated through this fire detection group that's in the southwest, or the south central United States. And they were able to outline where they thought the highest probability for fire starts were going to be. And those flames show you where the fires actually occurred. So, there's a bullseye there in eastern Oklahoma that might have been the poorest correlation, but pretty much everything is contained within that zone. And the Forest Service in Oklahoma and Texas pre-positioned resources well ahead of the event. Okay. Well ahead of the event, and they were able to request in seats, which are single-engine air tankers, ahead of and they were waiting. They were sitting there waiting for this. And they were able to contain what could have been a rather bad event in the southern United States. Now here's a beast, coupled fire atmosphere modeling. The folks in Boulder at OAR and at NCAR are working on this to be able to compute what is necessary to project fire spread and fire behavior in complex terrain. It's a downscaling problem. It's taking weather models that are at best 1.5 kilometers and putting them down into the sub-kilometer range and projecting how fires are going to burn in a community, through a community, or through complex terrain. So I know in Colorado there's a project going on with the state to demonstrate a fire behavior model as well. And we'll see what the results are. The results are not in yet, but it's using one of those Colorado fire models in terrain to model the fire behavior. And there's also an excellent Forest Service USDA publication, if you're not familiar with it. It's a publication on critical fire weather patterns. It's an excellent source of information on what we look at in terms of pattern recognition, critical events, and this covers everything from Santa Anas, which are typically thought of, to sundowner winds, to east winds, eastern patterns, breakdown of the upper level ridge, all this. The synthesis of knowledge of extreme fire behavior, and it's an excellent read if you're hungry for more information on critical fire weather patterns across the United States. And that's my last slide. So there's plenty of time for question and answer.
You mentioned, red flag warnings are just that. Doug Kammerer from WRC in Washington. And they really are just more watches than anything else. Because a lot of times you have red flag warnings, you don't actually have fires. But when you do have a fire moving on, are you able to issue something else? Are you able to issue some kind of a box that people live in, that those people know that that's where they are, so that when they can get the alert on their phone? I'm sure they do, but do you have that same coordination or coordinate power that we do with like a tornado warning or a severe thunderstorm warning?
It's not there yet. That's the end game. At some point, we'd like to warn by polygon, area affected, and we'd like to warn, like I said, for fire on the ground, and how it matches up with how we're expecting the fire behavior to match up. So the closest thing that we can do, and it's an external request to us, is to disseminate either the information they have or to put out a civil emergency message. That was done in San Diego in 2003. I'm not exactly sure if a CEM was issued by the Weather Service for any of the recent events. But what we really depend on is that forecast narrowing to the red flag, and that's where our information has typically stopped. And we're a disseminator of the external evacuation orders and emergency messages at this point. Where we'd like to take it is a more fire environment warning system.
And I think that would help us, I think, get that word out, as well to those people too. I mean, anytime you have a box that we can show and we can zoom in on that area, that would help. I think that would help the public as well and help us to inform the public. So yeah, I'd love to see how we do that moving forward.
Yeah, I think the inhibiting factor has always been with tornadoes and hurricanes. There's remote sensing capabilities. You can see it, you can know how it's responding. Where is it? Is it in a critical area? Pull the trigger and polygon it. Until goes, we really haven't had that capability.
Matt Safino, Portland. To follow up on Doug's point in question, there are times where I've had a red flag warning up for virtually my entire state. And I show that on the air, and I give a lot of qualifications about what that means and what it is, but it's interpreted by, I'm sure, the public and by my managers as the same as it would be for, say, a winter storm warning. And so what would you suggest we do? How would you like to see broadcasters handle red flag warnings, since that is sort of the final product, and we do display it on our warning maps? What would you suggest how we handle that?
I think it starts with the Ready, Set, Go program, is preparing people ahead of time. You might run something at the beginning of your season, a segment on how to clear out brush, what are the typical mitigating factors you can do as a homeowner to lead in. And then during the event, I really think since red flags are a fire management product, to make sure that the information is, the red flag means the conditions are
Favorable.
favorable. It does not mean your house is going to be affected, but if something is of note, if you see smoke, you have to start working or communicating. You can give calls to your fire department or police, not 911 or anything like that, but that's about the limit that we have right now, is once you see the red flag and you know it's a bad situation, communicating with the local emergency management officials. It's really not yet a Weather Service function.
Almost more along the lines of a watch than, okay.
It's very much a watch product. We call it a warning. It's typically been known as a warning, but again, where we would like to go with this is to make it a true warning at some point.
Steve?
Oh, yeah. Can I just jump in? Because I want to, Steve Weagle from West Palm Beach, NBC. I just wanted to kind of carry on with Matt's question. I think the term red flag warning, it doesn't tell viewers anything. And I think if there was a different term, it would be just easier for them to digest and understand.
In our social science report, we've done focus groups, and it's mainly been in the West. We did focus groups in Riverton, Wyoming, Missoula, just outside of LA, Medford as well, and Albuquerque. We've expanded through a public survey effort as we speak across the eastern United States and central. And we're presenting in that, I think it's 800 or 900 sample, different scenarios of products. Would you like to see, for example, fire storm warning? Something that could be boxed, something that could be one up from a red flag warning. So it's a known issue for the public. We're trying to address it with proper social science at this point. And again, that study is due out in March, and examining everything from the way we name products to, like I said before, not just the way we name it, but does the public need a different set from us in partnership with the land agencies? So,
Yeah, I just think it's confusing to them.
Mm-hmm.
Like, there's a new product from the Hurricane Center too, potential tropical storm cyclone,
mm-hmm.
which no one understands.
Yeah,
And yeah.
bomb cyclone.
Can I ask one more question?
You bet.
And this is about, and sorry, I stepped out for a few minutes, so you may have touched on this. But controlled burns.
Yeah.
I live next to a state park, and it's nonstop controlled burns. And my understanding is that's because we put out so many fires, we're trying to kind of catch up to what we're putting out to kind of keep the natural cycle.
Yeah, controlled burns are fuels treatment conducted by whoever. It could be a nature conservancy or bigger organizations like the Forest Service, BLM, and they use those spot forecasts that we have available. Like, I think the percentage is 60% of the 20,000 that we put out every year is for controlled burns. So they can't light a match unless they're under certain prescriptions. And the forecasts go out for several days as well, so you might not have a problem today, but 3 days from now.
I guess what I'm looking for are your personal feelings. Are they worthwhile?
I think they're definitely worthwhile, especially where people have moved close or didn't realize when they bought their house that they're adjoining a fire-prone area. So they definitely have an excellent track record or function of reducing fuels. Occasionally they get out of control. You know, you've all heard of Los Alamos, and that was a controlled burn that got out of the, that was because during the day of the incident, the forecast was spot on. They lit it. It was the extended forecast. It came back to life 3 or 4 days, and then that was at a time when the policy was only for a one-day forecast. So we instantly adjusted that policy to make sure that it's not just today, it's into the future. What could liven up this fire again if it's still creeping around?
Heath, Joe Murgo from WTAJ in Altoona. Two things that you can answer kind of on there. Is social media a blessing or a curse? Because I know at times we've had issues where we had fire departments putting out, hey, there's a red flag warning in effect for today, and it wasn't for their area. You know, I want your opinion on if you like social media like that. The other thing to comment on, and I didn't know if you're aware, might as well prepare in your planning this year. The state of Pennsylvania has now, to raise money and get taxes, any Tom, Dick, or Harry can buy any kind of firework and shoot it in the air.
Yeah.
Do you think that's going to be an issue?
Well, it's always an issue. You saw that graphic. Anytime that you have a higher-powered explosive. Yeah, I wasn't aware of the legislation, though. So that's interesting. The original, your first question, the social media. I think it's been overall more of a blessing, I would say. We're able to communicate and tweet information that provides a more consistent message from the forecast office. And that's across the whole weather enterprise, not just fire. The first snow of the season, people getting that information out. Reporting fires and things of that nature. Yeah, you're going to get the occasional false report, a red flag warning, oh my gosh, what's happening, and it's actually not for your area. So I think just that information exchange, in the end, what we have IMETs out there for, and what we have the spot forecast for, is to take everything that's coming at us, and the agencies have been trained, and they do a very good job of it, of tuning out. They hear it, they ask the question, hey, I heard so-and-so said we're going to have like a horrible fire season. What do you think? So it opens the conversation more on the people that actually have to fight it. Now, the public is a little more difficult. We don't know how it's going to be received. So again, the social science aspect of what our calls to action should say. Do we need a different product set? That's the kind of things that we're studying right now. And we know it's not where it should be.
Yeah, Craig Setzer from Miami. Who gets to name the fires, and how do they come up with some of the names? Some of them make sense, you know, the Thompson Fire, and then there's the Little Bunny Fire, or the Chaturanga Fire.
The local unit that responds names it. Sometimes it's after a drainage that it's on, or the hill that the Bumblebee Fire, or you know, Stinky Skunk Fire, or whatever. There's been some funny names out there, but it's usually something identified with that piece of land, and it's the local unit.
Howard Bernstein, WSA Washington. Getting back to the social science studies you're doing for naming things, is there a timetable for when there might be something? And I know that big organization with NWS, not the fastest, not the slowest, but is there a timetable where we might see, even though they've undergone a hazard simplification process recently, where they might be adding something like that? Do you have any idea when that might happen?
I'd say within 3 years, we're going to be able to really enhance things. You know, the hazard simplification process has been slow in fire weather because we haven't done the social science research. But as far as changing the calls to action, that's a quick fix. That's something that we can do in policy, and to make sure when we put out a red flag warning that we're messaging properly for the public. Redesigning the red flag warning program to focus on fire on the ground is a lot more of a bear, because it's tied into the culture of how things are responded to, the acceptance of weather service involvement in evacuations and getting that messaging out. That's more of that's kind of what that's why we're not dragging our feet, but we're working appropriately to make sure our messaging is out there. So I'd say from the time that March report comes out, I would like to, within 3 years, have something for the public.
Do you see that similar to severe thunderstorms and other things where it'd be polygon-based warnings in that regard?
Yeah.
Because I think that is something where it took a little while. I think people are getting more used to that, where the old county warning was the old way.
Yeah, the polygon, the area affected, it's more precise than just a county warning area. That's kind of what we're after, along with having discussions and making sure our warning system is morphing into fire on the ground, and making sure our detects are related to what critical terminology we have to use.
Different thought I was just having. A lot of times when you're driving through a national park or something, you see the old signs, and they're manually putting up the wooden board, low, medium, and high. Do you foresee them ever advancing to a point where maybe more of a digital sign that could be more immediately updated? Or would that take away from the kind of the charm and quaintness of the wooden signs?
I've seen them on the overpass You know, I've seen fire messaging on the overpass systems in the West, where you go, high fire danger, or I've seen Walgreens putting up on their digital thing, fire danger, red flag warning. That's very interesting.
But if you're in the middle of the park.
If you're in the middle of the park, yeah, it's something that you got to do at the information booth. They always put up the forecast there, but digital in remote areas, I'm not sure, honestly. It's people are used to that Smoky Bear when you're first driving in, and that's your fire danger.
Pushing more of the mobile app?
Yeah, the mobile app idea, definitely. And we're doing that. That's one of the goals of the spot forecast as well, to have the capability of requesting those through the mobile app and getting a forecast back.
Hi, Jim White, University of Colorado. I'm curious about how far out into the future you're planning in terms of fire, because for example, that a warmer and drier west has led to a change in field types. You've got the pine bark beetle rearranging your trees out there. What are you guys thinking about, and how far out are you looking in terms of changes in the fire seasons?
On the Forest Service side, they're looking out. Honestly, they're looking out decades. They know things are changing. They have strategies in place right now to, when they recover through the burned area recovery teams, they plant and they rehabilitate accordingly, expecting for changes, expecting for warming and drying and lengthening the season. So I know on the fire agency side, they plan for these fuel regimes to be changing, and they respond appropriately. On the Weather Service side, we're kind of, fire weather borrows a lot. So as advances are made in climate forecasting and those types of things, we kind of take the fruit that drops off the tree from that. So I don't think we have any direct fire planning for fire weather forecasts, but we do have the sensible elements that will be changing: temperature, wind. Are the events going to get more extreme? And it's more connected to our climate research. But on the fire agency side, they're definitely planning for things to change.
Heath, Jennifer Broom from Denver. I'm curious, when your IMETs are in the middle of an incident, how much interaction do you get with the air teams? I know you're dealing with everybody, the boots on the ground, working with them, but how much that's the most dramatic video that I think any of us can show on television, is those, dumping the buckets, where people see that's what people relate to. Okay, they're here, yay.
Yeah.
We're getting a grip on the fire, but do you get to interact person to person with those pilots?
Every morning before they go out, it's either going to be 5:30 a.m. or 6 a.m. That's what our briefing is for. We have an incident action plan as well, where we put up that matrix of numbers. And so we have verbal communication in the morning every day with the pilots, the crews, the overhead teams. When they come back, if we're lucky enough, we especially are in tune with the crews. We debrief them. They turn in hand weather reports for where they were. Hey, you said it was northeast. It was the opposite direction all day. That happens. It happens a lot. So we take those and we adjust forecasts accordingly. So depending on who you're talked to, you got to, I've been personally involved with evacs, where I've been on with the pilots and saying, you got a window, go now. And it's usually through the communications. And it's very incident command system, ICS. So if we report to the communications 10, or we get on that channel 9, which is typically channel 9 is everyone can hear it. The pilots can hear me speaking, saying thunderstorm approaching the area between 1530 and 1600 hours. Expect winds here, over and out, basically. 20 seconds, boom. But yeah, we're live but it's a rare event. We only do it once maybe twice on a dispatch.
We have 10 minutes.
Mitch, Heath, you talked a little bit about GOZAR and things that you've learned from that. What are you hoping to learn more about? What have you seen from it? Obviously this is the first fire season you guys have had it, and really, for all of us to look at it, it's just astounding what we can now do with this. What are you finding from GOZAR and hoping to put into practice?
Wow. We're currently in a process of validating what our role is in all this. You know, we own the satellite data, and we've developed the algorithms through very high-level discussions. We want to work with the Forest Service and the other people who have typically are in the business of detecting wildfire and reporting it to see what our role is in that. I know some of the local forecast offices have already instituted some standing protocol. For example, if they see a GOES-R detection in a critical time, they're instantly authorized to issue a spot forecast for that. So we're getting those types of local practices tied to the capabilities of knowing, we know where the fire is, we know how hot it is, we can see it, you know, sub-pixel. It's amazing. And then where we would like to take it is to standardize across the board what our role is in reporting and how the algorithms that are detecting what the characteristics of the spread are to the warning system that we have. For example, in Southern California, you see the detect or whatever, we could theoretically just issue a firestorm warning. You know, that's new terminology, but we haven't really verified or validated. Is that the name that we should call it for the public? Because I've heard that term floated around, firestorm. It creates that second or third level of, oh my gosh, you know, this is it. You know, this is our 1 in 10-year event. So yeah, we are very hopeful that the algorithms that detect the heat, the radiant spread, how clean the burn is, because you can go in and look how much of the vegetation is blackened. It gives an idea of what the radiative intensity is of the fire. So we're hoping to use that information to change the way we do things.
Heath, Todd Santos, CBS Buffalo. Curious if your IMETs collaborated all your mesoscale expertise, because you're so local to all of this, to the air pollution modeling side of things. I mean, so many of us are in the communication side of things, and when we've had other fires, even large fires locally that aren't wildfires, we've tried to communicate that there's an inversion or where the smoke plume may be heading and that sort of thing.
Yeah. Brand new to the incident command teams are, have you heard of air resource advisors? They're actually called ARAs. Everybody's got a little acronym that are out on fire, but they are a growing segment of the incident command team. So what the meteorologist does on fires that are very local, they sit down with the air resource advisor, and they, at least at the team level, they decide as a team how the smoke's going to, you know, what the volume is, where it's going to go, run some high split models, readjust that mobile NSEP grid to better deduce where the wind fields are going to transport the smoke. How that gets to the state regulators is, I believe, I'm not exactly sure how the ARAs communicate that out, because I know that they're a resource for the incident command team, but not necessarily a direct interface to the state. Now, during public information meetings, everyone's there, including the smoke people. I mean, they're, at least in the local communities, that word is getting out through the public meetings and the PIOs, the public information officers, on the fires.
We've done traditionally bad with that in New York, specifically when there's an issue. It takes 3 days, and then they say, well, you know, they're going to test it, decide what the particulate matter concentration is, and all. It's not really timely. So that's why I was curious, you know, the interface in between.
Yeah, again, has the potential of identifying the real heavy concentrations of PM 2.5 and modeling it.
Heath, I have a question. This is Dave Jones with Storm Center. I would just like to know, like, a little bit broader perspective. What are your biggest challenges that you have within the Weather Service in providing the information that you want to provide to those decision makers? And the second part of that is, what capabilities do your partners want from you? What is it that they're asking you to provide them so they can really jump on these fires and get a head start?
Yeah, the challenges that we have, obviously with the volume of our being dispatched increasing, making sure that we're not getting burned out, making sure we have adequate numbers. We've always been able to meet the requests that have come in, but we keep ramping up and adding equipment and adding locations, and again, pulling those eastern resources for western fires. And the other way around, too. During hurricane season, we send western people to the southeast if necessary. So that is a challenge, personnel. The second challenge is getting our warning services better defined for the public. You know, Mr. Smith, I go out on my back deck, I see a smoke plume 3 miles away. What do I do? You know, is that a weather service function to step in and say, well, it's going to be on your deck in 3 hours? So that is another challenge, is making sure that our red flag messaging for fire agencies does not send a different message out, you know, and I think it all boils down to consistent and clear messaging for the public, you know, what our role is in that. We're still challenged with knowing where to step in and where to message. As far as what the agencies are asking us to do, it's kind of, in some respects, they don't know what they don't know. They wait to see innovation. They let us present it to them, and then they ask us, hey, what can you do with this thing? So the goes are thing, they're asking a whole bunch of questions. How is this going to affect the way we do business? How will this change our ability to respond tactically? How can the vegetation help us respond, or the vegetation monitoring, how can that help us respond in a prescribed fire sense? They're asking always for more accurate information and forecasts. So yeah, as we improve and we add grids and we go to the NCEP modifications that you heard of earlier in the conference, they're really leaning heavily on the ensemble approach to this. They want a deterministic forecast, but how the ensemble range or envelope works, they're asking for that too. How does that information improve our capabilities to respond?
We have time for one more question. We have 2 minutes left before we take a 15-minute break. Matt, do you have a...
I'm curious if you guys do any forecasting for transport of distant smoke, say from fires, you know, when it's the slow season for you. If we're getting smoke coming down, say from Alaska or even Siberia, that impacts visibility, not so much, you know, breathing concerns, but visibility in parts of the West. Do you guys track that at all?
Yeah, that's done through, first of all, through NESDIS. They do that kind of monitoring. You can see the projections and where the smoke is going via satellite. And NOAA Air Resources Lab, NOAA ARL, they do forecasting. It's actually part of the grids that run out. You can actually do a smoke transport or surface smoke grid. They're available. And it's run through NOAA ARL.
This is great. Heath, thank you very much. How about a nice round of applause for Heath? It's been terrific. Thank you.